हेलो स्टूडेंट्स, आज का हमारा सॉलिड स्टेट फिजिक्स 1 का टॉपिक है लाइन इम्परफेक्शंस। A linear disturbance of the atomic arrangement which can move very easily on the slip plane through the crystal is known as dislocation. The dislocation may be caused during growth of crystals from a melt or from a vapor, or they may occur during a slip. The line defects, as the name implies, extend along some direction in an otherwise perfect crystal. One such defect can therefore be considered as the boundary between the two regions of surface which are perfect themselves but out of register with each other. In case of crystals, it arises when one part of the crystal shifts or slips relative to the rest of the crystal such that displacement terminates within the crystal. However, if the displacement does not terminate within the crystal but continues throughout the crystal instead, it may not introduce any defects in the crystal. This defect is created along a line which is also the boundary between the slipped and unslipped regions of the crystal. The defect is commonly called the dislocation and the boundary as the dislocation line. Two basic types of dislocations are edge dislocation or Taylor or obtuse dislocation or Berger dislocation. These are usually two extreme types of dislocations. Any particular dislocation is usually a mixture of these two extreme types. These may be regarded as the components of a general dislocation. Edge dislocation. An edge dislocation may be described as an extra plane of atoms within a crystal structure. It is accompanied by zones of compression and of tension so that there is net increase in energy along a dislocation. The displacement distance for atoms around the dislocation is called the Berger vector. The vector is at right angle to the edge dislocation. Berger vector is determined by drawing a rectangle in the region being investigated by connecting an equal number of atoms on opposite sides, as shown in the figure. If a certain region contains an edge dislocation, the circuit will fail to close. The dotted line PP given in the figure 6.1 is the Berger vector. The edge dislocations are represented by the symbol perpendicular and T denoting the insertion of extra plane from the top and bottom side of the crystal respectively. These two configurations are called positive and negative edge dislocations. These symbols also indicate the position of the dislocation line. Fig 6.1c shows the atomic view in an edge dislocation. पढ़ेंगे अपनी अगली वीडियो में, तब तक हमारे साथ रहिए। हमारी वीडियो अच्छी लगी तो चैनल को सब्सक्राइब कीजिए ताकि हमारी आने वाली हर वीडियो आपको आसानी से मिल सके। थैंक यू।